This is a walkthrough of problem 3 on exam 1 in module 7 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 3 is the Bainbridge mass spectrometer uses a velocity selector, shown right here, to ensure all the ions enter the field region at the same speed. And then you have this magnetic field region to separate ions by their mass. The magnetic field is out of the page. In the magnetic field region, there's two ions. One's traveling in this radius, the one's traveling in this path, a smaller radius. Define the ions moving in the tighter circle as A and the other as ion B. First of all, are the particles positive or negative? The magnetic force when they enter the field region is downward. So we put our thumb in the direction of the velocity, which is to the right. The fingers are pointing out of the page. The palm should be facing downward. That's the direction of V cross B. That's the direction of the force, which means the particles are positive. That's the answer to part A. Part B, which ion is heavier? Well, they're moving the same speed. They experience the same force. F is equal to ma. The larger mass will have the smaller acceleration because m times a is constant. The acceleration is v squared over r. Since they have the same v, the heavier ion must have the bigger r. And of course, you can just say that right away. It makes sense that the heavier ion is going to be traveling in a bigger arc than the smaller mass ion. So B is the heavier ion. Part C, A has the bigger acceleration because they have the same force. F equals ma. A has the smaller mass. It's going to have the bigger acceleration. When you push on something with the same force, the smaller mass is going to have the bigger acceleration. Part D. If we look down the barrel of the velocity selector, here's the velocity selector. The E field's downward. It's much easier to look down the barrel, so that's what we're going to do. E field is downward, which means the electric force on a positive particle is downward. The magnetic force, the force, must be upward. We have to get the direction of the field now. The force is upward, V is into the page, so the magnetic field must be to the left. The direction of V cross B is upward. It's a positive particle, so the magnetic field must be to the left. And if you look at this figure, we have to convert to this figure because this is the figure they're asking about. If it's to the left in this figure, it's into the page in the original figure. So your answer should be into the page. That's problem 3.